For today's lesson, we're adding and subtracting rational numbers, and today we're focusing on decimals. Now, as a reminder, rational numbers are any number that can be written as a fraction, but today, instead of looking at fractions, we're looking at decimals. And I like to think of decimals as wholes and then parts out of tens, hundreds, thousandths, or 2 and 3/10ths, or 4 and 400ths. So a whole and its parts. We're going to solve these with the same strategies that we've been using before. First, are there any double signs? Yeah. So I rewrite without the double negative. Next, I'm going to estimate, round it off, and see what kind of answer I get. So when I estimate, that's about a -4 and 8, which gives me about 4 for my estimated answer. Now I need to actually solve. I'm going to come over here to the side and take that 8.216, and I'm subtracting 3.5. Now, in the same way, with fractions, we needed a common denominator. With decimals, we need a common denominator as well, and we get that by lining the decimals up so that the thousandths are with the thousandths, the hundredths are with the hundredths, the tenths are with the tenths, and the ones are with the, wholes, the ones. Now I can subtract. 6 minus 0 is 6. 1 minus 0 is 1. 5 I'm not going to take away from 2, so I borrow 1 and rewrite it as giving 10 more or giving me to 12. Now 12 minus 5 is 7. 7 minus 3 is 4. And my final answer would be a positive 4 and 716 thousandths, which is close to my estimated answer. Example 2, I again have a double sign, and I'm going to rewrite it. So if I'm adding -8 and 216 thousandths, really I'm taking away that 8.216. And when I estimate, I notice that my signs are the same. So I'm going to combine to give me -12 because I've rounded those off. When I go to actually solve it, I'm going to notice that for my estimation, I combined them, or I added them together. So I line the decimals up again, and this time I add the 8.216 and the 3.5. That gives me a 6, a 1, a 7, and an 11. Now, when I write my final answer, I'm going to notice that it's not close to my estimate because my estimate is a negative. And I almost forgot my negative. My final answer is -11 and 716 thousandths because I had -3.5 and then I took another 8 away, giving me a total of -11.716. For example 3, I have another double sign, -20 plus 8.216. I'm going to estimate, and you can start doing these estimates mentally. You don't always have to write them down. That's about -20, or I guess exactly -20, plus about 8 gives me an estimate of -12. I come to the side, and I'm going to say 20 subtract 8.216. Oh, all of the zeros with subtraction. Well, in order to be able to subtract 6 from 0, we're going to need some numbers in that place, and right now we have nothing. So I'm going to borrow all the way from the left side. The 2 becomes a 1, and now this is 10. But I then have to borrow from that 10 to give 10 here. But then I have to borrow from that 10 to give 10 here. Then I have to borrow from that 10 to give 10 here. And now when I go to subtract, I have enough in the top to take away the numbers in the bottom. 10 minus 6 is 4. 9 minus 1 is 8. 9 minus 2 is 7. 9 minus 8 is 1. And then 1 minus 0 is 1. This gives me -11.784 for my final answer. I compare it to my estimate, and I came pretty close, so I am feeling confident in my answer. Here's one for you to try, so pause, try it on your own, and play to check your answer. I do have a double sign, so I rewrite -7 8/10 minus 3 99/100. You can do the estimation mentally. I like writing it out so you guys can see where my head's at. Gives me about -8 minus about 4. Oh, and I need to show that it gives me about -12 for my estimate. Now I'm going to do my actual solving over to the side. 7 8/10, 3 99/100. And since they're both being taken away, or both negatives, I'm going to combine them by adding. I've lined my decimals up for my common denominator, and I get 11.79. My final answer is a negative because I had negatives to start and I added more negatives in the end.